Having a look at practice question set number 1. Starting with question number 1. It says a 47-gram ball. Right away, I'm going to circle that, right? I don't want grams. 47-gram, 0.047 kilogram ball is hit with an initial velocity of 70 meters per second at an angle of 30 degrees up from the horizontal. What's the vertical component of the ball's momentum? Now, if you were in my class last year, you might be thinking right now 5 words. If you weren't in my class, you know exactly what to do. Mr. Kader taught you everything that I taught you. He just might not have used these 5 words. That's all. Bernardo, you remember what those 5 words are? I don't like funny angles. In fact, I use those words so much that somebody last year bought me this water bottle. It says, I don't like funny angles on it. Okay, remember that. Whenever you see an angle that's not 90, 30 degrees is not 90. That's what I call a funny angle. And I say, every time I say, I don't like funny angles. So what do you do if you don't like funny angles? Get rid of it. Turn it into something that's not a funny angle. Turn it into X and turn it into Y. Does that make sense? All of us have done that. We just may not have used that phrase, that's all. Now we're all going to start. So let's do that here. I got 70 meters per second. Let's draw this out. I get 70 meters per second. Here's an X component. Here's a Y component of that. And here's my 30-degree angle. Let's solve for X. Solve for X using a trig function. That's adjacent. That's hypotenuse. Adjacent and hypotenuse go with cosine. Cosine 30 degrees is equal to adjacent over hypotenuse. Now, on my answer sheet, I don't actually have the answer there because, well, as it turns out, I didn't need to solve for that. 60.62177 from my calculator here. Now, the Y component is the opposite, right? So I'm going to say sine 30 degrees is equal to opposite over hypotenuse. So what did I just do? I saw a funny angle that was 30 degrees, right? Like it looked like this. What did I do with it? I changed it into this and this because I like this better than I like this. Now, we want to find the vertical component of the ball's momentum. Just like we wanted to find the final momentum in some of those questions we had for homework over the weekend. We said P is equal to M times Z, find VF. Now we're saying P is equal to M times V, find the vertical velocity. What's the Y component there? 35, right? 35. Ends up giving me 1.65 kilograms meters per second. A is our answer. Does that make sense? Now, if we had asked for the horizontal component, how would that have changed? Yeah, we just use X, that's all, right? And we would have got, I think the answer is B if we did that. So, man, like you see how easy it is to make a little mistake, right? You solve for X and Y like we just did. Don't read the question carefully. Use X in P is equal to M times V, and you're going to get B and think you got the right answer. Just be careful. Good? Okay, 30 degrees. Mason, what do you think when you see 30 degrees? 5 words. What do you say?
Disgusting.
Disgusting.
I don't remember the 5 words.
I, repeat after me. I,
Don't.
no, you're not.
Sorry.
I don't like funny
Funny
angles.
angles.
I don't like
I don't like
funny
funny
angles.
angles.
I don't like funny angles.
I don't like funny angles.
I don't like funny angles. Good, either do I. So what do we do with it? We get rid of it. We take it off to the side. We do our little thing like we just did right here and turn it into an X and Y. A few years ago, I asked somebody, what do we do? I asked the same question. What are the 5 words? He said, I don't like funny angles. I said, what do you do with it? He said, kill it. Seems a little violent, okay? But the sentiment is there. We got to get rid of it, turn it into something else, right? We don't want to ever see that 30 degrees again. Look, it's gone, right? Once we do this thing over here, it's gone. We're never going to use it again. That 70 is dead to us. We're never going to use it again. We're going to either use the 60 or the 35. Got it? Okay, so this is our physics 30 part, right? This over here, this in black, is really a physics 20 analysis, right? This is one of those things that we got to remember from physics 20. The good news is we're going to do this a lot in physics 30 of vector analysis, so it will come back to you over time, over the next little while. As we use it lots, it'll come back to you if it hasn't already come back to you. Okay, let's do not question number 2 because I shouldn't have put it on there. Put it on there by mistake. Question number 3. A little bit of a tricky one as well, actually. 2-kilogram cannonball is fired out of a cannon at 30 degrees to the horizontal. Cannonball reaches the top of its path. Its momentum is a magnitude of 800. Let me see the picture there. There we go. What's the horizontal component of the cannonball's momentum when it left the cannon? Anybody have an idea here? Yeah, Bernard? 400? Where'd you get that? 400? It's not even an option. Where'd you get 400?
I got 400 meters per second because the horizontal velocity does not change over the whole path.
Okay.
There's nothing to affect it.
Okay.
And you take the 800 kilograms meters per second and you divide it by the 2 kilograms, and that gives you meters per second.
Oh, but you're not looking for the, oh, I see. I see what you're saying. Your logic was actually good, except you didn't answer the question. It said, what's the horizontal component of the cannonball's momentum, not velocity? But your logic was very good there, actually. It was very good. Bernardo said, if you didn't hear that, as this ball, or as this cannonball, goes through its, what's the shape of that path called? Parabola. As it goes through that parabolic path, vertically it accelerates, but horizontally it goes at a constant speed, because there's nothing to slow it down or speed it up, right? So if its speed doesn't change, its momentum doesn't change. So if it was 800 horizontal at the top, it's 800 horizontal everywhere, isn't it? Here, 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 here. It's 800 everywhere. Vertically it changes. But why would it change horizontally if the velocity doesn't change horizontally? Right? The good news is, Bernardo, you were solved for velocity, and that's not there. So you would have figured that out eventually. One more, question number 4, I'll have you guys work on for a few minutes, and then we'll take a look at that one after you've worked on it. All right? Give you a few minutes here, starting now. Okay, we want to find the total kinetic energy. 1/2 m1v1 squared plus 1/2 m2v2 squared. Listen, some of you don't like writing down equations. I get that. Sometimes I skip steps too, like not writing down equations. Guess what happens? Usually I get the right answer. But every once in a while I make a mistake, and I make a mistake more often if I don't write down stuff like showing equations and so on. So we really should, right? Notice as well that it's 1/2 mv squared plus 1/2 mv squared. What's total mean? What's a synonym for total? Sum, okay. What does sum mean? Add. Right, we're going to add them. We're not going to subtract them. Some people this morning did the same thing as some of you guys did, subtracted these kinetic energies. We don't subtract kinetic energies. You want to find a total, you want to add. Okay? If you have $20 in your bank account, you have $10 in your wallet, and you have $100 in your piggy bank, then you add all those together and you get $130. You don't start subtracting when you want to find the total money, you add. So we add here as well. 1/2 of 1,200 times V1 is just 20 squared, plus 1/2 of 1,000 times 24 squared. That gives us, oh, by the way, how come I use 24, not negative 24? Yeah, because kinetic energy is a scalar, right? We don't want the direction. Even if it was at a funny angle, we wouldn't deal with that. I don't like funny angles, but if it's a funny angle with a scalar, I don't really care. Not a big deal. We add these together, we end up getting a kinetic energy of 5.28 times 10 to the 5 joules. So that means the answer is either going to be A or B. Now let's find the total momentum. M1v1 plus M2v2. How many people solve for both kinetic energies together like I did here? How many people solve for one, then the other, and then add them up? Okay, doesn't matter, does it? It's the same thing. What do we got here? 1,200 times 20 plus 1,000 times 24. Is that right? Well, notice the space that I've left in front of the 24. Kind of made it a little obvious. How come I left that space? Well, that should be negative, because momentum is a vector. Add these up gives me 0. Is it possible to have 0? Sure. The momentum of one cancels out the momentum of the other. The answer is B. Lots of people between the 3 classes today have gotten D. And man, it's close. It's close. If you said D, you subtracted kinetic energies. Okay, we never do that. We always add. I think if you said A, what was the problem there? Oh, if you said A, you just made both velocities positive. You forgot the south part of it. Good? All right.